Get ready for an interplanetary adventure. In the coming decades, a bold vision is set to become reality, establishing a new civilization on Mars, with millions of people calling the Red Planet their home. With Elon Musk and NASA leading the charge, humanity is steadily marching towards this extraordinary feat. Amidst these advancements, a recent discovery on Mars by Elon Musk and NASA has sparked a whirlwind of excitement and speculation. Could this be the evidence of alien life we've long speculated about? How will this groundbreaking finding impact our plans to inhabit Mars? Join us as we delve into the details of this intriguing discovery and explore what it means for the future of human life on Mars. The red sands of Mars are stirring with secrets, and we're on the brink of uncovering them. Let's embark on this cosmic journey together. Mars, with its distinctive red hue and extreme conditions, captures the fascination of scientists and explorers. Named after the Roman god of war due to its blood-like color, a trait derived from the Greek god Ares, it stands out in the solar system. Its surface is coated in regolith, iron-rich dust and rocks, which oxidize to give Mars its iconic rusty look. Unlike Earth soil, Mars' regolith lacks organic material. The thin and cold Martian atmosphere means liquid water is rare on the surface, though hydrogen detections hint at possible salty subsurface water. Mars also experiences vast dust storms and Marsquakes, making it a key focus for solar system exploration to unravel its many mysteries. Mars, despite being half the size of Earth, has an equal amount of dry land and hosts the tallest mountain and the longest valley in the solar system. Olympus Mons, a massive volcano, rises 17 miles, 27 kilometers high, dwarfing Mount Everest. The Valles Marineris Canyon system, discovered in 1971, spans about 2,500 miles, 4,000 kilometers, comparable to the width of Australia. This immense canyon was likely formed by crustal stretching, with individual canyons reaching up to 60 miles, 100 kilometers wide. While the existence of recurrent slope lineae suggests intermittent briny water flows on Mars, this remains a topic of debate among experts. Valles Marineris, Mars' immense canyon system, boasts a central section up to 370 miles wide where various canyons merge, hinting at a past filled with liquid water. Nearby, Olympus Mons, one of the solar system's largest volcanoes, spans about 370 miles, its shield volcano structure formed by extensive lava flows. Mars's surface, rich in volcanic features ranging from tiny cones to vast lava plains, suggests the possibility of ongoing minor volcanic activity. Channels, valleys, and gullies etched into the Martian landscape speak of ancient water flows, some stretching up to 1,200 miles long. Subterranean water, potentially supportive of microbial life, is a subject of interest, especially considering the 2018 study that hinted at the presence of oxygen-rich salty water beneath the surface. This diverse terrain, predominantly flat and low-lying, adds to the planet's enigmatic allure. The northern plains on Mars, among the flattest and smoothest areas in the solar system, may have been shaped by water once flowing across the planet's surface. These plains are generally at a lower elevation than the southern hemisphere, suggesting that the northern crust could be thinner. This disparity between the north and south might stem from a massive collision early in Mars's history. The age of Martian terrain varies, as indicated by the differing number of craters in each location. The southern hemisphere houses the planet's largest crater, Hellas Planitia, spanning 1,400 miles, 2,300 kilometers, in diameter. In contrast, the younger surface of the northern hemisphere features fewer craters. Some craters on volcanoes hint at recent eruptions, as lava flows may have covered older craters. Additionally, certain craters display deposits resembling hardened mud flows, possibly indicating impacts on water or ice beneath the surface. In 2018, the European Space Agency's Mars Express probe discovered a possible underground lake on Mars, similar to those found in Antarctica. This 12 4-mile-wide body of water might contain a slurry of water and grains, indicating potential subsurface life. Additionally, Mars Express observed a significant icy zone in the planet's Korolev crater. The Martian poles and latitudes up to 80 degrees in both hemispheres feature layered deposits of water, ice, and dust, hinting at a history of atmospheric deposition. Despite Mars' extremely thin atmosphere and harsh conditions, like carbon dioxide, snow clouds, and intense dust storms, it shares similarities with Earth, such as a similar day length and axial tilt, leading to seasons. However, Mars' elongated orbit causes more extreme seasons compared to Earth. Mars, with its vivid red appearance and harsh conditions, is a world of contrasts that intrigues both scientists and explorers. Named after the Roman god of war, its surface is coated with regolith, an iron-rich dust lending it a distinct rusty color. The Martian atmosphere, being thin and cold, casts doubt on the presence of liquid water on its surface, yet hints of subsurface hydrogen suggest the existence of brackish water. Known for intense dust storms and Marsquakes, Mars is an excellent candidate for exploration to uncover its unique mysteries. NASA's InSight mission has unveiled that the Martian crust is significantly thinner than Earth's, with a thickness of 14 to 45 miles. The planet has two moons, Phobos and Deimos, discovered in 1877 and named after the Greek god of war's sons. These moons are small, irregularly shaped, and potentially composed of carbon-rich rock and ice, with their origins still a subject of debate, possibly being captured asteroids. Mars exploration has revealed a fascinating landscape, highlighted by features like Olympus Mons and Valles Marineris. The Viking landers provided the first close-up images, showing a world with ice caps but no apparent life. The Mars Odyssey's 2001 discovery of subsurface water ice suggested a complex history. Phobos, Mars' moon, is on a collision course with the planet, potentially leading to significant future changes. Debates over Martian life were sparked by discoveries like the ALH 84001 meteorite and studies indicating possible organic molecule formation, fueling ongoing curiosity and exploration efforts. In 2003, NASA's Spirit and Opportunity rovers embarked on a groundbreaking journey on Mars, uncovering evidence that water once traversed the planet's surface. Surpassing their initial 3-month lifespan, Spirit explored until 2011, and Opportunity until 2018, revealing Mars' dynamic history. NASA's Curiosity rover, landing in Gale Crater in 2012, discovered signs of an ancient habitable lake system and recorded fluctuating methane levels, hinting at possible biological processes. Complementing these missions, the Mars Reconnaissance Orbiter and MAVEN, operational since 2006 and 2014, analyzed the Martian atmosphere and surface. The European Space Agency's Mars Express and the Trace Gas Orbiter orbit Mars 2, enhancing our understanding of this enigmatic planet. In 2018, NASA's InSight lander began analyzing Mars's interior through Marsquakes, while the Perseverance rover, launched in 2020, searches for ancient life signs in Jezero Crater. Perseverance has captured over 282,000 photos and recorded Mars's sounds, deepening our knowledge of its atmosphere. Its mission, focused on Jezero's delta, aims to uncover biosignatures in the sedimentary rocks. Mars's features, like Olympus Mons and Valles Marineris, provide insights into its history and potential for life. The unexpected discovery of igneous rocks in Jezero Crater has prompted a re-evaluation of Mars' geological past, with ongoing exploration and plans to return samples to Earth for detailed analysis. NASA's Perseverance rover, a key player in advancing Mars exploration, is diligently collecting rock samples for a potential return to Earth. Equipped with 10 sealed tubes, it holds an atmospheric sample, a control sample from Earth, and 8 rock cores. After overcoming initial challenges in rock sampling, the rover's subsequent drillings have been successful. Preparing for a future mission to bring these samples back to Earth, Perseverance is strategizing either to deposit them on Mars for later retrieval or to hand them off to a returning lander, ensuring diverse options for this groundbreaking endeavor. Human missions to Mars, planned for the 2030s, face challenges due to prolonged microgravity and radiation exposure, affecting astronauts' health and their adaptation to Mars gravity. NASA's Artemis program, aiming to establish a moon base by the end of the 2020s, serves as a precursor for Mars exploration. Despite advancements, a Mars journey still takes 6 months with current technology, highlighting the importance of ongoing research, like that on the ISS, to prepare for these challenges. NASA isn't alone in its ambition for manned missions to Mars. China and Russia have also expressed intentions to send humans to the Red Planet. Elon Musk, SpaceX's founder, established the company with the goal of aiding human colonization of Mars. SpaceX is developing Starship, a fully reusable deep space transportation system envisioned to facilitate human settlement on Mars. SpaceX has already been contracted by NASA to use a version of Starship for lunar landings later this decade. Musk is confident that Starship will eventually transport humans to both the Moon and Mars, although the exact timeline remains uncertain. Mars continues to captivate us with its mysteries and potential. As we push the boundaries of space exploration, who knows what astonishing discoveries await us on the Red Planet? Stay tuned for more cosmic adventures.